So this is a continuation of section 1.4. We're going to be talking about even and odd functions in this video. So first off, even functions, they are functions that have like a symmetrical or symmetry with respect to the y-axis. And so the best typical example that I can show you this is probably a parabola. So parabolas are typically x squared, and when you draw them, let's just draw a simple one here. Notice that a parabola has a symmetry along that y-axis, right? This half is the same as this half, like mirrored to each other. So oftentimes when you do this, you'll notice like when x equals +1, it is the same value as x equals -1. And so that's what we call even function. And when this is the case, in order to test if something's an even function, is when the negative x value equals the same as the positive x value. So when you stick in the negative x value and you stick in the positive x value, you get the same y values, is what it means to be an even function. And odd functions are a little bit different, almost opposite, but not quite. So odd functions have this symmetry that is with respect to the origin. Now, when you have a symmetry that's respect to the origin, it kind of has a radial symmetry. And I'll show you what I mean here once I draw an example. So I'm going to use the cubic function because that is a great example to kind of show you an odd function. So x to the third power is what we call a cubic function. And so if you were to draw a cubic function, remember it also starts at the origin. And since the slope is 1, you would go up 1, over 1, so it'd be plot. And so this side goes up. And the other side's the opposite. It goes to the left 1 and then down 1. So notice how I did the opposite slope when I had to plot the other side, right? I had to go to the left and down instead of right and up. And so that's what I mean by the radial symmetry. So if you have a symmetry that's at the origin, respect of the origin, and you have one point, then the other one's going to be kind of like directly, almost diagonal in a way, to the other part. So that's what we were talking about radial. And I also want you to notice, like, if this point right here is x equals 1, then the y value there is 1. Whereas when x equals -1 over here, the y value is -1. So because in this case, you have these values here, when f of x equals -x, then the y value ends up being the opposite sign, is what this notation means. And so what we can do to figure out if something is even, odd, or neither is to use this type of notation. We're going to plug in a -x. Notice that all of these f functions are all positive, right? These are the positive x values that they've already shown. So all we have to do is plug in -x into the function and see if we get what is the result, to check if it's an even or an odd. And if they're neither of these cases, then we can say it's neither. So with the first one here, I have a absolute value function. And so if I were to plug in, let me not use red. It always looks so harsh when I do red. Let's do blue. So if I plug in -x into an absolute function, right? Let's just think about what absolute functions do for a moment. So absolute functions make things into positive, right? So this negative sign ends up being a positive anyways after the absolute value is taken. And so this ends up being absolute value of x, which is the same function as before. So because it ends up being the same when you plug in a negative value, that means this is an even function. And let's just think about it for a moment. When you have a absolute value function, that's the function that looks like a v, right? If it has a v, most of the time it has that symmetry, right? This side would be equal as this side. So typically, I can already see the symmetry here, but you do want to check using this plugging in a negative x to check if you result in the same function. So in this case, this definitely is an even function. This one here, again, I'm going to be plugging in negative x into f. So that means that this x cubed, if I were to rewrite this and plug in a negative x, this is going to be to the third power minus negative x. Now, let's just think about this for a moment. If you have a negative number to the third power, that's like negative, let me write this to the side. That's like negative x times negative x times negative x, right? That is 1, 2, 3, 3 negative. So when you multiply these two, it ends up being positive. Multiply it one more time, it ends up being a negative. And if you multiply all of these x's together, this is going to be x to the third power. So this ends up being negative x to the third power. Now these two have two negatives here, so they end up being a positive x. So now, looking at this function here and looking at the original one, I want you to notice how the first term are opposite. This one's a positive, this one's a negative. And then this one is a negative and this one is a positive, right? So in this case, because the signs are completely opposite of the original one, this is what we call an odd function. Okay, if the signs are completely flipped for every term, they are odd. Another way I can show this is if I were to take this negative sign and pull it out. So I'm going to pull out a negative sign in the first term and in the second term. So when I do that, I leave behind an x cubed and a negative x. And so when I really look at this, this here is the same as this function, right? The only difference is it has a negative sign in front, which works with the odd function definition. So in this case, definitely a odd function. All right, in this one, you have x to the second power plus 1. So we're going to plug in that negative x value. And if we plug in negative x and I square it, well, if you square a negative sign, it's going to end up being positive. So this ends up being x squared plus 1. And that is the same function as before, right? This is the exact same function. So this is what we call a even function. So we just happen to get another even function. And last but not least, we have this function here, and this is x to the fifth power. And if I were to plug in a negative x, so this would be negative x to the fifth power minus 1. Now, because this is an odd power, this here, if you take a negative power to negative 1 to the odd power, you're going to get back a negative sign. And then this will be x to the fifth power minus 1. So when I look at these two, right, comparing the original with the negative, this is a negative in the first term, this is a positive. So these are opposite. But then if I go to the second term, this is a negative 1, but this is also a negative 1. They are not opposite of each other. So in order to be an odd function, they need to be opposite. So this should have been a positive 1, but it's not. So if this is the case, this is when we can finally say this is a neither. This is neither odd or even. And the reason why is because in order to be an even function, you have to result in the same function, and these are definitely not the same. In order to be an odd function, each term needs to be opposite signs of each other. So these two are opposite, but the other two weren't opposite. So in this case, this is a neither function.